Okay, so we have started the fuzzy logic and we give you introduction about the fuzzy logic history and also the basic concepts. And we covered also the fuzzy sets versus crisp sets or classical sets. So this is classical one. The degree of membership is either 0 or 1. But for fuzzy sets, you have some graduality here in degree of membership. It is 1 here, it is 0, starting from 7. Between 3 and 7, any value has a certain degree of membership. For example, 4 has 0.75 degree of membership and so on. So you want to have either 0 or 1. This is crisp set. And this is also fuzzy set. You have C here, the degree of membership is between 0 and 1. It is in the gray area. So car speed, you can have slow, medium, and fast. And as we mentioned earlier, in the slow, medium, and fast, where is the pen? Here it is. So this car speed is, we call it linguistic variable. Slow, medium, fast is linguistic values. So you can, if you have the crisp set or classical set, you can see here the hard limit of the slow, hard limit of the medium, and so on. But definitely for fuzzy, you have graduality in changing between slow and medium and fast. So at any speed, you can have degree of membership of the fast. So this speed belongs to fast with a degree of membership 0.75, and also it is a medium with degree of membership equal to 0.3 and so on. Degree of membership of slow definitely equal to 0, and the slow function is as such. So the value is beyond 50, degree of membership equal to 0. So this is the fuzzy set. And of course, this is as usual when we define the universe of this course. أو فضاء العينة زي ما بيقولوا. It's between 0 and 120 here. So this is, of course, this is continuous. Universe of this course here, continuous variable. You have here the speed is ranging between 0 and 1. Can take any real value. Sometimes we have the universe of this course is discrete, as we will see in next slides. Fuzzy linguistic variables are used to represent qualities spanning of a particular spectrum. For example, temperature is a linguistic variable, and these are linguistic values. Temperature could be freezing, very, very cool, warm, hot. So these are the values. And of course, you can define the membership function for each value here. Freezing, you can say between, if you have classical, so you can say in the freezing, for example, between minus, for example, 20 to 0, minus 20 to 0. Cooling from 0 to whatever 10 or 20 degrees, and so on. You can have some hard limits here, but if you express it as fuzzy variables and also fuzzy values, then you freezing, you have it here, and then you have gradual change, and then you cool. This is the function of the cool, and this is the function of warm, and this is the function of hot. So in real life, if you measure a temperature, for example, the temperature is here. So if you measure the temperature, of course, as we mentioned earlier, in fuzzy logic, you have some if-then rules. And this is where the fuzzy inference will take place. So you have several if-then rules here. If the temperature is freezing, then you have this. If the temperature is cooling, then you have this. If it is, of course, if you have another variable, temperature, pressure, مثلا. So if the temperature is high or the temperature is freezing and the pressure is low, then you take this action. If the temperature is cool and the pressure is medium, then you take. So you have here like you can say, if we have here 4 variables, and if we have another variables which is the temperature here, 4 values, and if the temperature has, for example, low, medium, and high. So we have here 4 values, and this linguistic variable take 3 values. So how many, and I'm asking you, how many rules that can be written here? What do you think? How many rules that we can develop? And you take all the possibilities. If the freezing and low, freezing and medium, freezing and high, cold and low, cold and medium, cold and high, warm and low, warm and so on. So 12, yeah, 12 rules, right? So you can write here 12 rules. If this is 4 values and this is 3 values, you can develop here 12 rules. Okay, this is in general this time this. And you can have here 5 values, you can have here another 5 values. So you can build 25 rules, or 7 values and 7 values, you can build 49 rules and so on. So you can write here about 12 rules. So when you measure the temperature and you found it as such, and assume also the pressure has low, medium, high. So this is the pressure. Okay. So you measure temperature, and this is the case. And you measure also the pressure, and this is the case. So pressure belongs to medium and also belongs to low. This is low, and this is medium. So I am asking you, if this is the case, we measure the temperature. Now, in real life, we are measuring, and then we do this fuzzy inference, and at the end, we will see the action, how much the action. It is similar to the example that we started with of the restaurant, when you measure the quality and you measure the surface. So if you assume that, and if you given, or if you assign a number out of 10, for the surface, and another number out of 10 to reflect the quality. So how to proceed in order to get the action, the final action? So in this example, we measure the temperature. This is the case. Temperature here has a degree of membership with the hot and also with more warm. And the pressure here has low and medium. Now I am asking you, how many rules will be excited here? Excited means the output of these rules is not 0? What do you think? How many rules we have values, degree of membership, or how many rules will be fired? The others will be zeros. So what do you think? How many rules?
4.
4, yes. We have 4. If the temperature is hot and the pressure is low. So this is the case. If the temperature is warm and the pressure is low, this is the case also. And if the pressure is hot and the temperature is hot and the pressure is medium, so this is the case. And also for hot and low, this is the case. So here we have 4 rules out of 12 will be fired. Fired يعني has a value. It is not 0. So what we will do later, we will combine these 4 rules together. We will see the outputs of these excited or fired rules, and then we will end up with the final action later on. Final action later on. We will see this later on. As we mentioned, we have different stages. What we are doing here exactly is phasification process. Phasification process. Now we convert from numerical values of the temperature, which is, for example, 85 degree numerical value, and the pressure here 1 bar, 2 bar, 3 bar. So this is 3 bar, مثلا. So this is the numerical value. We convert the numerical values to linguistic values, to low, to medium, to mid, warm, hot. So this is the phasification. And then we will see the fuzzy inference, and then at the end we will see the dephasification. So we convert back from the linguistic values to numerical values. Nasser, do you have a question, Nasser?
Yes, Doctor.
Go ahead.
Could you go again about this is 12 status? What is it still for me? I'm confused because we have 4 status: freezing, cold, warm, and hot. But what is the other 3 values? I'm having 1 and 0.
No, why 1 and 0? This is the pressure. And assume that when you measure the temperature, and we have another fuzzy variable, which is the pressure. Okay? The pressure also, you can assume it low, medium, high. Am I right?
Okay.
So if you have 4 values here, and the 3 values for this variable, so how many rules that we can build here? With each value of this, it could be with low or medium or high.
Yeah.
So could be with this. And you
I get it, Doctor. I got confused because I'm thinking there is a temperature and there is a pressure and there is, for example, a speed, and there are these the 3 variables.
Oh, لو 3 variables, definitely you multiply by the number of values of the speed also.
Okay, I get it, Doctor. Sorry, thank you.
So, okay. Degree of membership, assume that also, for example, the people height, if you want to measure or to classify this, you can assume that greater than 180 centimeter, then you can say this is tall, and below this is short. And this is crisp set. You have hard limit between short and tall. In fuzzy, which is more closer to natural language of thinking of the human being, you can say, no, this short, and we have gradual change here, and also for the tall you have some gradual. So in between 160 and 200, any length here 190 has a degree of membership of tall equal to 0.75, and degree of membership for the short is 0.25. Yani you have some graduality in the transition here between the values. And definitely, naturally, as we mentioned earlier several times, 180 is tall, but what about 179? Can you consider it short, مثلا? And 180 is tall? No, this is not the case. Yeah. So you must be taller than this line to be considered tall. So of course you have some degree of membership. So this one could have 0.8 مثلا. This one could have, or this one could have 0.6, this 0.4. Maybe this will be 0 degree membership of tall and so on. So this is the height, and this is the this one is degree of membership of tall is 1, and this one degree of membership of tall is 0. خلي بالك هو degree of membership of tall is 0, يعني هو not tall. انما لو عرفنا بدل instead of tall we said short. We need to measure the degree of membership of short set, not tall set. So for short, this will be 1, and this will be 0. Okay. If you want to define with respect to short rather than tall. So with tall, this is 1 and this is 0, but this is for crisp set. For fuzzy set, you have some graduality here. This one will, in terms of tall, it's 0.3, and this one is almost 0.95 or something like this. So you have a gradual change between this. Classical set is mathematically defined as such: A equal to the numbers x, where x is greater than 6. So the membership of any value of x is either 0 or 1. If you define x equal to 2, يبقى 0. The degree of membership is 0. If x is greater than 6, يبقى the degree of membership is 1. So this is the case. So you can see the hard limit here. But for the fuzzy sets, you have, this is the definition of the fuzzy sets. Fuzzy set A is the value and the degree of membership of this value. X is belongs to the universe of this course. So the fuzzy set here is defined as a pair, not a single value, but as a pair here. The value and the degree of membership. The value and the degree of membership. So this is the pair in fuzzy set. So this is a fuzzy set. Could be مثلا temperature high, low, freezing, cool, pressure, speed, and so on, slow, high, and so on. So this is the membership function that will be defined in order to get mu A of x. This is the value, and you get the degree of membership. And this is the universe of this course, or called the universe. And I have some hands here. Hashim, Muhammad?
Yes, I want to ask about can one value represented or contains 3 areas? I mean 3 representative of the temperature, for example, cold, high.
This will, yeah, okay. So it could be, يعني in principle, it could be. As I mentioned earlier, we have several shapes of these membership functions. It is not necessarily to be triangular or trapezoidal as such. It could be any value, and also you can optimize the shape and the shape in terms of triangular or trapezoidal or Gaussian or sigmoidal. So this is the type of the function, and also the shape. You may have this triangular is very sharp as such. Okay, you can have it as such. Not necessarily to have this is 0 and you start the other one. No, maybe the other one could start here. So in this case, if you have any value here, so this value will cut 3, will cut this, will cut also this value, this function, and will cut also this function. يعني you can, in principle you can. Okay, Hasham?
Yeah, it's clear. Thank you.
Okay. Abdullah Yusuf?
Victor, you said that fuzzy logic does not have hard limits. However, there is defuzzification or if-then rules. So I think the hard limits will appear again in the if-then rules, isn't it?
The hard limit?
Yeah. So in the end, we will need to define to determine whether a person is short or tall, or the temperature is cold or hot in the end. So this is a hard limit, isn't it?
لا يا عبد الله يعني انت you have يعني when you have if then rule as such, when you say مثلا for example let us write one of the let us say, let us take very simple example and try to develop. يعني انت and I assume you are expert in electrical engineering, and if I give you a motor, for example, this is a motor. This motor, of course, supplied here by a supply. Okay, and I ask you, okay, I need to control the speed of this motor. Okay, I want to control the speed of this motor. So let me measure the speed and acceleration. Okay, Abdullah, are you following me?
Yes.
I would like to control the speed of this motor by changing, of course, the voltage here. Of course, if you increase the voltage, you may have some flux or the field winding. Anyway, and you can, by controlling this voltage, you control the speed. Okay?
Yes.
Assume that you are measuring the speed and the acceleration. Okay, now if I ask you, okay, if the speed is low and the acceleration is negative, I can define the speed. I can define the speed to low, medium, high. Okay, and I can define also the acceleration as negative, 0, positive. Okay, these are the values of these two linguistic variables. Is it clear, ya Abdullah?
Yes.
Okay, now if I ask you based on your experience, in electrical engineering on electric machines, if speed is low, يعني that means that you have a speed below the rated value. You want to fix the speed as 3600 RPM, and you measure the speed and you found the speed is low, below this 3600, which is the rated value. And also you measure the acceleration and you found the acceleration is negative. معناها انه في deceleration. يعني the speed is low and also the motor is decelerate. Did you get the point? What kind
Yes,
of action? Then, this is the action, but then, what do you want to take an action here?
Increase the voltage to adjust the speed.
Okay, so voltage increase is high. This is the output. The voltage increase, this is the linguistic variable, and you can give this linguistic variable different high, low, medium, and so on. Okay?
Yes.
This is just one rule that can be developed here. You can also say, you know, if the speed is high and higher than the rated, and the acceleration is positive, معناها انه the voltage increase is negative, let us say, or voltage decrease in this case. You need to decrease the voltage. مش كده ولا ايه؟
But my question, how is it different from the normal or traditional if-then rules?
What is the traditional if-then rules?
Yes.
What is the traditional if-then rules?
If you, for example, for the speed, if it is less than a certain number, then do something and so on.
Oh, you want to say, you know, instead of fuzzy, I can say if the speed lower than or less than, for example, if it is 3600 RPM the rated, عاوز تقول انه مثلا 35 مثلا RPM. Okay?
Yes.
Then you take this action. Now this is the problem, ya Abdullah. This is the problem that we are trying to avoid. And when you say this a numerical value, طيب less than this, طب if it is 3501, it is just above this. يعني 3501, do you think it is very far from this below the 3500?
No.
Come on, this is why we are going to fuzzy logic. لأنه ضمني بهارد limit. زي الطول كده قلنا ان 180 is this is a short and this is a tall. Do you think in 179 is not tall? You classify it as short? Well, we need some graduality here. We need some graduality, and this is natural language.
But you said that we need to convert it into linguistic variables. So this is like a hard limit. This is
No. This is not hard limit. If you measure 3501, this is your measurement. You have here, let us say low and medium. So this is the low, and this is the medium, and this is the high, مثلا. For example, and this is trapezoidal membership function, which is not a problem anyway. So now you measure 3500. This is 3500 here. So this 3501 have a degree of membership with the medium and the degree of membership with low. And here is the graduality. And you are not classifying this value as higher than 35, and so this is the hard limit here. And here you assume this is 35 belongs to both this and that, and this low and medium with certain degree of membership.
And based on this, you take an action based on both values, not one.
Based on the fuzzy rules, everything rules. So you convert this numerical value to linguistic value. You have it high or low with a certain degree of membership. You have it medium with a certain degree of membership. So you convert the crisp or the numerical value to linguistic values, and you take these linguistic values and go to if-then rule. If the speed is low and the acceleration is negative, then so you evaluate this rule. And when you evaluate this rule, the output will how much the voltage increase. So you can say, no, Allah, yes, I will take the action, the voltage is high. Then you need to convert high to a numerical value in order for your controller, this is fuzzy logic controller or any controller, to take an action here. So you will convert high to numerical value, and this numerical value will be taken here. 10%, 3%, 5%. So this is what we call the defuzzification. So we have fuzzification at the beginning. We fuzzify the quantities. We do the inference, fuzzy logic inference, and then we do defuzzification. This is the procedure,
Okay, one last question.
The
value of the voltage will be based on what? What is high in this case?
أنت you define it. يعني أنت you define high or low. Similar to this membership function. You can say, okay, and I will, this is the voltage, and this is the membership. So this is low, this is medium, this is high. Medium and high, this is the voltage increase. The voltage increase, you can say, okay, between 0 and 50 volt, مثلا, or between 0 and whatever. So you have it high, you have it low, you have it medium. So medium means, if it is here, medium, you add here 25%. So you defuzzify from medium to a numerical value, which is here. And the defuzzification we will consider it in next slides. How to, if you fire here several rules, it is not only one rule, but you have 4 rules here. How to combine these rules, which gives you high, medium, very high, and so on. How you combine these 4 rules together to find the action that you need to take. This will be discussed in details, how to do the defuzzification.
So in this case, we will consider both the value of the speed, the membership functions of the speed to find the exact value of the voltage, right?
Membership value of the speed?
Yes. Will we consider it to take the to determine the voltage value?
Yes, as I mentioned, and we have here several rules. We have here 2 variables. If the speed is defined 3 values, and the acceleration also 3 values, so we can construct 9 rules here, right? We can construct 9 rules. And when we measure a certain value for the speed here, you will speed and acceleration. Definitely each value could belong to مثلا two linguistic values here, يعني low and medium مثلا. فأنت you will fire 4 rules here. out of the 9 rules, you will fire 4 rules for a certain value of the speed and the acceleration. So these four rules will be combined together in order to get the actual action here. In order to calculate the then part, the consequence part. This is called the precedent part, and this is the consequent part of the if then rule. So we have 4 values here. We will combine them together. We will end up with the, for example, voltage will be medium, and if medium, we go to this and we calculate how much the increase.
Okay, it is clear now. Thank you.
Okay, any other question? Hassan Ali?
Yes, doctor. For the bearing and the, for example, if I have a protection temperature in the bearing of the motor and I want it to be a fuzzy logic set. So when it's hot, let's say hot is 90. And then I want to add a time on it. So when it reaches 90, 91, 92, for like, let's say 10 minutes. It can tolerate it, does not trip the motor.
Yes.
But after 10 minutes, it can take an action to trip, for example, the circuit breaker connected to the motor. Can I add this without adding a clock or a timer in the fuzzy logic?
No, actually, in order to design some kind of controller here, you need to measure, as you mentioned, I need to measure the time, okay, and the temperature. So you need time and temperature. Am I right? Did I understand your question?
Yes, yes. For example, sometimes we have the crisp controller, which is when it reaches 90, it trips immediately. For example, if I wanted to monitor it just for maintenance purposes, I want to see it does not trip. Like the fuzzy logic does not trip it at least for 10 minutes.
Okay, you can have such. Okay, let us put it here. You can say temperature, you measure the temperature.
Yes.
This is the temperature. And this is temperature here, low. Low means below مثلا a certain value, or temperature is medium or around 90 degrees, or if the temperature is high. You need مثلا, for example, if it exceeds مثلا, if it exceeds 92, 93 مثلا, it should be tripped. مثلا على سبيل المثال.
Yes, doctor. Yes, doctor.
So you measure the temperature here. مثلا, for example, this is 80, and this is 90 مثلا. And of course you can have this and so on. You can set all these values. By trial and error, as you mentioned, you can have this or that. So this is the temperature, and you have also the time. If the time is short, or the time is medium, or the time is long. Long means 10 minutes. And you can tolerate until 10 minutes مثلا. If it is below, and this is 5 مثلا, and so on, and this is 3 degrees, 3 minutes, and so on. Okay? If you have such such mechanism here, you can have like a 9. You can develop a 9 3 times 3, so 9 if then rule. So when you say if the temperature is high, which is 90 degrees, and the time is long, greater than 10 minutes. So then you can, your action is trip. And your action is a signal goes to the circuit breaker to trip. Okay, or to isolate or to disconnect. Now, if the temperature is low, and even for example, the time is medium or high, you can take an action to increase مثلا or do extra cooling or remove any the disturbance that causes this in terms of overloading or whatever. It depends on your, of course, process. So
it's clear now, doctor. It's clear.
Okay.
Thank you.
Right. Abdullah, you still have a question or?
No. I forgot it.
Okay. Okay, so this is the crisp, this is the fuzzy set. Fuzzy set is defined as a pair of values and the degree of membership. And this is the universe of this course. As we mentioned, we can have a continuous or we can have a discrete, as we will see in a few minutes. A fuzzy set is totally characterized by a membership function. We will see different shapes of membership functions right now, inshallah. So this is the discrete of universe. Assume that we are asking you, or we can define a fuzzy set of sensible number of children. So what is the sensible number of children? Somebody can say 0, no children at all, or 1 or 2 or 10, or unlimited. Okay. So you can have this X as 0, 1, 2, 3. طبعا the number of children is a discrete number. Could be this is a discrete universe of this course. Okay. You can say, okay, if we define the membership function as such, if this is defined as such, if 0 as a degree of membership equal to 0.1, for example. So 0 degree of membership is 0.1. If one child, the degree of membership is 0.3. So 1.3. 2, degree of membership of 0.7. 3 is maybe optimum, it is 1. And 4 children, 0.6, 0.3, and 0.1. So this is the fuzzy set, which is the sensible number of children. As you can see here, the universe of this course is discrete. You can have also a fuzzy set. You can define a fuzzy set as a desirable city to live in. What is the desirable cities to live in? You can say مثلا Dammam, you can say Jeddah, you can say Riyadh. So these are the universe of this course. So this is of course discrete. And you can define that Dammam is degree of membership is 0.9, Jeddah's degree of membership is, and Riyadh's degree of membership is as such. And you can have this pair, the variable and the degree of membership, variable degree or the value and degree of membership. So you can have some discrete universe of this course. Fuzzy set B about 50 years old. About 50 years old. This is a continuous. Could be 49.5, 49.7, 40.3, whatever the age. So this is a set of positive real numbers, continuous. And you can define B as the value with the membership. You can define the membership as whatever. You can define it any triangular, trapezoidal, and any membership function you can define here. So if you have X, if you say, for example, 49 years old, so this 49 years old will will be have a degree of membership equal to a certain value, depends on the membership function that you define here. So if you define the membership function as the Gaussian as such, this is the membership function of around 50 years old. This is 50 years old. So you are around either positive or negative, higher than or lower than 50 years old. So we can define this membership function. So if you have any age, like for example, 0 مثلا, 0, if x equal to 0, how much is the degree of membership? How much is the degree of membership? What do you think? Nasser, Hakami?
0
ليه 0؟
from the graph.
لا هو الجراف يعني طبعا هو فيه فاليو هنا بس very small يعني if x equal to 0, if x equal to 0, so you have 5 squared 25 plus 1 26, 1 over 26 is approximately 0.04.
Yes.
So 0 and 0.04. If it is 50, if x equal to 50, so this will be equal to mu of 50 equal to 50, 1. If it is 70, if x equal to 70, then mu of 70 with respect to this set as defined before, so mu equal to of 70, you have it 70 here, minus 50, 20 over 10, 2 square, 4 plus 1, 5, 1 over 5 equal to 0.2. So this is the degree of membership here. So you can define B as, you have, these are just examples, 0.04. If it is 50, 1, and 70.2. Of course, we cannot enumerate all the variables, all the pairs, this is a continuous. So you have, infinite values of x, and for each x you have a degree of membership. Is it clear? Any question? طيب, membership functions, you have several membership functions. Triangular is the most or the widely used one. This is in MATLAB, you have tri membership function. This is the shape of the triangular in MATLAB. And as you can see here, this function is defined by the starting, the median value, and also the end. So when you define it in MATLAB, you put these 3 values. You put the initial value, you put the median value, which is the maximum here, you have 1, and you put the end value. So you define this function by these 3 parameters. And this is the name in MATLAB. Trapezoidal, you have 4 variables here, 4 values or 4 parameters to assign the shape of the trapezoidal. This one, and this one. So you have it trapezoidal, trap membership function. In MATLAB, you will find this name, and this the 15778. 15778. So you characterize the trapezoidal function by defining these parameters. Another one, which is the Gaussian. Gaussian here, you need to define the Gaussian. You need to do what? Gaussian is defined by the mean value, or average value, or mean value, and also the standard deviation, 2 and 5. So this is Gaussian membership function. The standard deviation is 2, and the mean is 5. The mean here is 5, and the standard deviation is 2. So when you select this membership function, for example, you can characterize it by the standard deviation and the mean value. This is also in MATLAB. In MATLAB also you can have the two-sided Gaussian. يعني two Gaussian function. Actually, this one is completed as such, and this one is completed as such. So you combine both. So this is a Gaussian 2 membership function. So two-sided Gaussian function, and you have here 1, 3, 3, 4. That means you have here the first Gaussian function, and the second Gaussian function. So you can have here the standard deviation of the first, and mean of the first, which is you can see here 3, and the standard deviation of the second Gaussian, and the mean of the second Gaussian, which is 4 here. And you can see here, this one, if you complete it as a Gaussian, will be as such. So the mean is 4 here for the second one. And this one, if we continue it as a Gaussian, it will be as such. So this is the mean here, which is 3. The mean for the first, the mean of the second. So you can have such a shape. As you can see here, in the shape of the membership function can take several shapes here for the membership function. It's not only triangular or this. You can have even more and more. This is the Bill function, generalized Bill function, generalized Bill membership function. You can characterize this function by these 3 parameters. This function is defined as 1 over the scalar value of 2 to the power b here, x minus c over a, and you need to define a, b, and c. So this is a, and this is b, and this is c. So when you define these 3 parameters, you can characterize the generalized Bell function as such. You can have a sigmoid. This is the sigmoid. Usually when you have high, مثلا temperature is high, this is usually the case. Instead of having you have a trapezoidal as such, or you can have it gradual as such. A sigmoid function is defined as 1 over 1 plus e to the minus a multiplied by x minus b. So a and b should be characterized in order to have the shape of this. But 2 is a, and 4 is b. So at 4 you have 0.5. This is usually the case. When if b equal to 4, then at x equal to 4, then we have 0.5, and then this is ranges from 0 to 1. If x is infinity, then it becomes 1. If x equal to minus infinity, so this becomes 0. So this is 0 here, and goes this. Difference of 2 sigmoids. And you can have a shape of difference of 2 sigmoids. Now we have the sigmoid function here, and the sigmoid function is defined by a and b. So you can have a difference between the 2 sigmoids. So you have a and b for the first, a and b for the second. And this is also a function in MATLAB. So you can define this as a1, b1, and this is a2, and this is for b2. And you have one, this is exactly, you have one sigmoid as such, and the other sigmoid is multiplied by negative, so you have it as such. Okay, you have both, and you take the difference. So you can have also product of two sigmoids, product of two sigmoid functions. You can have also characterized by this. This is for the first one, and this is for the second sigmoid, A and B, and this is A and B for the second sigmoid. What I want to say, there are several shapes you can try. You can select among them. You can, if you want to optimize your fuzzy logic controller, then you can select whatever gives you better accuracy or whatever. So we have other functions, zero membership function, or Z membership function, similar to Z letter, and you have S also. This is S membership function. This is Z membership 3 and 7. As you can see here, 7 is 0, and this start at 3. I mean 3 and 7. That goes as such. So these are functions also in MATLAB. You can have them here 1 and 8. So this will be a function of S function, and the by also function. You can have by function here is 1, 4, 5, 10. This is 1. This is 4 when it reaches 1, and 5 when it reaches at the end of 1, and 10 when it reaches 0. A lot of membership functions you can select among. Is it clear? Any question? طيب الفuzzy partition, as we mentioned, if you have any fuzzy variable or linguistic variable, you can divide this to several values. Like مثلا the age, you can have it young, you can have it middle-aged, you can have it old. So you can divide, or you can do several partitions for the fuzzy variables. As you can see here, the age is partitioned to young, middle ages, and old. And this is we of course discussed this several times for the speed, for the temperature, for the whatever. Now, in classical sets, you have some operations on the set. Like you can do the union, you can get the intersection of the sets, you can get the complement of the set. This is in classical sets, and we need also this one here in fuzzy sets. لأنه in any fuzzy rule, if the speed is high and this and how to calculate it, this and the acceleration is low, for example. So this and or, you can have and or. So how to calculate this part of the fuzzy of the if statement and this part of the statement? What is the final value of this precedent or the first part of the if then rule? We need to calculate this, and then we have then here, after calculating this, we will go to the action here and we calculate, and then we defuzify to get a numerical value here. So what we need to do now is to see how to carry out the and or complement on fuzzy sets. You can see here the logic and. This is the logic and logic gate or AND gate. You have if A and B as such 0, 0, 0, 1, 1, 0, and 1, 1, 1. The output will be 0, 0, 0, 1. Yani we have here if A and B. There is an output if A and B are true. The output is true if A and B are true, both are true. So you have this output here. If you look at this output, you can see no 0, 0, 1, so the minimum is 0. 1, 0, the minimum is 0. 1, 1, they are equal, so it's 1. So this and logic here can be represented as a minimum of A and B. If you have two inputs, you can compare which one is the minimum, and this minimum gives you an execution of the AND. Okay? And for example, if you have a degree of membership of the speed, you measure the speed and you have it membership here equal to 0.8, and the acceleration is low, and you measure the acceleration and you found the acceleration has a membership degree of membership equal to 0.2, for example, here. For this rule, or for this part of the if-then rule, the first part is 0.8, the second part is 0.2. If we have an AND here, the value of this part equal to what? Equal to the minimum value, which is 0.2. But this is the firing value of the first part of if-then rule. So this is the minimum value. If it is AND, the minimum value. You have OR logic gate also. If either one have or both have 1, then the output is 1. So you can have 0, 1, 1, 1, which means no maximum. So this is the maximum. Or represent here is the maximum value of A and B. So if you calculate this rule, and we have here not AND, but we have OR, so the output of this part will be 0.8, which is the maximum of 0.8 and 0.2. This is for OR. For minimum, for 0.8 and 0.2, this is for AND. So if you have this AND or OR, you can calculate according to this rule. Of course, the complement, if A is 0, the complement is 1. If 1 becomes 0, so it is 1 minus A. It is 1 minus A. So that means if you have a value here, if the rule is just if the speed is not high, you measure the degree of membership for high. Not high, 1 minus. If it is high, for example, here 0.8, then for 1 minus 0.8, it will be 0.2. So this part will be 0.2 if the speed is not high. I mean, this is 1 minus the membership value that we have here. So this is the not operator, which is 1 minus A. So this will give you an indication or introduction to how to calculate the if-then rule. And we are calculating only this first part of the if-then rule at the time being. If we have here or, and, not, and so on, you can handle this. So when you measure the speed and the acceleration, and you get the degree of membership, you go to the if-then rule and see what we have here, or and then we can get the resultant value of the first part of if-then rule. We have also a subset. A is a subset of B. That means the membership for the defined on fuzzy on the set A is definitely below or lower than or equal to this complement 1 minus. The union is the maximum value. The union is the maximum value. The intersection is the minimum value. And when A intersects B, if this is the fuzzy set, which is a combination here between this, or intersection between A and B. So the membership to the C is a minimum of A and B. Okay. This one represent what? Or ولا and? This intersection represent what? Or ولا and?
Or.
Which one? Union?
Yes.
Union is or, the operator, and this is and operator. Okay. So if you have here A and B, then you take the minimum value. If you have A or B, you take the maximum value, as we explained before. Okay? Do you have any question? Okay, this is the and, this is the intersection. This is the A set, and this is the B set, or B function. So and is the intersection. The intersection is here. This part. This is the intersection, which is the minimum. And you have here B is lower than A. So we will take this A, this B. And then up to this point, till B is lower. And we have here A is lower. So we use the minimum value. So this is the, you know, the intersection or the AND operator. And for the OR operator, this is the maximum of A and B. So at this part, A is the maximum, and at this part, B is the maximum. So this is the union here, which is OR. And not طبعا, of course, is 1 minus. So if this is A, this is not A. If A is 1, then this becomes 0. If this is 0, this becomes 1. As you can see here, A is a subset of B. You can have, if you have these two sets, A and B, can you show us what is not A? What is not A? And this is A. What is not A? Set. Not A and 1 minus A. And it is like, you know, like this. When this becomes 1, this becomes 0. And you have it as such. When this becomes 0, this becomes 1. So this is not A, as you can see here. طيب what, let me remove this. What is A or B? A or B. So this is A or B, maximum. A and B, the intersection, which would be this part only. So you have this as A or B, maximum value, and you have A and B, which would be you know, the intersection here. Okay, now we have the membership functions, and we can do the operation of and or not on the fuzzy sets. So let us move now on how to calculate the if-then rule. This is the typical or the standard format of if-then rule. You have if, this is antecedent, then this is the consequent part. So you calculate at the first, you calculate this part, and based on this value, you know the value of this. And usually, if this is true, then this consequent will be true. If it is 50% true, this will be 50% true also. If it is 20%, this is 20%, and so on. So, rule 1, for example, if motor speed is slow, then voltage increase is high. And if this satisfied, then the voltage, then the consequent also will be satisfied. If motor speed is slow and the acceleration is high, then the voltage increase is low. This is just examples of the if-then rule. Interpreting an if-then rule involves two steps. In order to execute if-then rule, it needs two steps. First is to find the value of the antecedent, value of this part, and then you get the value of this part. Evaluation of the antecedent. This is what we call the falsification, as we mentioned earlier. You convert from the numerical values to fuzzy values. The inputs and applying any necessary fuzzy operator. You have here and if you have two variables, مثلا speed or acceleration, so definitely you have here a certain operator, either and or so. So you calculate this antecedent at the beginning, and then your application of the result to the consequent. If this is satisfied by 0.2, this will be satisfied by 0.2. If this is satisfied by 100%, this will be satisfied also by 100%. So the implication, if B is true, then Q is also true. B leads to Q. If the fuzzy logic, if B is true to some degree of membership, then Q is also true to the same degree of membership. And if 50% of the precedent or the antecedent here, this gives you 50% of the consequent here. Nasser, do you have a question, Nasser?
Yes, Doctor.
Yes, Doctor.
Yes, please.
Compared to generic algorithm that we have a weak solution, we can create a good new shelter from that one. Is it the same that I am making a fuzzy area or a gradient area that it will help me later on to get a good solution by AI or not?
Yeah, it is not.
I'm trying to get what is the if we want to solve a real problem like minimization or multi-objectives. So how that is helping me that I'm identifying my fuzzy area or the gradient area, that one?
Of course, if you have some optimized parameters, if you have some optimized parameters, x1, x2, x3, and so on, you can define some linguistic values of x1, x2, x3. You can define some of the membership functions of x1, low, high, medium, and so on, and x2, x3, and so on. Okay? So when you have any numerical value of this optimized parameter for a certain solution, you can see what your objective, and also objective is a fuzzy variable, and you can have it also with some linguistic values. The objective is high, minimum, low, and so on. And if you have this if-then rule, you can see how many if-then rule fired for a certain values of x1, x2, x3. You have numerical values of those. You convert them to linguistic, and you fire some of the fuzzy rules, and then you can do fuzzification here or defuzzification to calculate how much the objective. And of course, if you have others, you can do the same. Did I answer your question?
I think I'm still confused. Are we going to take later on just a simple example that how we build just a simple question, for example, minimization, maximizations, using this fuzzy concept?
Okay.
We need to feel how I can build. In the previous, we can build by any method we talked before to solve any problem, because we need to solve any case later on by using this one. So it is a request that we should have a simple
Okay.
question that we start and we build that one and we get the answer. Very simple one, please.
It is better now to see the fuzzy logic controller rather than optimizer. If you want to feel this fuzzy logic controller, you have a process here or the plant here, you have some measurement like a motor here, and you have the omega and the acceleration, and you have this omega and the acceleration to the fuzzy logic, and then you take this is the fuzzy controller and this goes to the plant. So this would be the process here. And as we mentioned, we define the omega and the alpha, and here the speed and the acceleration. We can define them as minimum, low, high, medium, very high, very low. And you can divide it as 7 values or 3 values or 5 values. It doesn't matter. And then you have some if-then rules here with the experience. Your experience is embedded here in if-then rules. And then you can take the action accordingly to the measurement here. So this example would be very clear in to explain how the fuzzy logic work better than the optimization, Nasser.
Okay. So
we have an example in the fuzzy logic controller later on.
Yeah, what I mean, how we link it with the problems. It's not necessary for me to be optimization. That's what you said, Doctor. Thank you. This is maybe the control, maybe the to find the better.
We will take a complete example of fuzzy logic control.
Okay, thank you, Doctor.
Okay, but
And
this will be at the end.
Okay, no problem.
And we see how to calculate this if-then, how to do defuzzification. When we discuss all these issues, then we have a complete example on fuzzy logic control.
So I will be patient until then. Thank you, Doctor. And by the way, time is over.
Time is over. Okay, let us stop here. Continue next class, inshallah. So if you have any question, please ask. Otherwise, you can leave. Fawzan. Fawzan.
Yes, Doctor.
Yes.
Yeah, I was. It's like a compliment to Khoi Nasser a question about the. We saw in the literature some method, optimization method, using the using the fuzzy logic as a hybrid. A hybrid one, we can say. They use the genetic algorithm, for example, with fuzzy logic or whatever.
Yes.
So if it's possible, Doctor, if we can see how the integration between the two methods here, like how can we utilize the fuzzy logic in such or the application of using fuzzy logic in with such evolutionary algorithms?
Okay. Yeah, again we are discussing about the hybrid techniques. How to use fuzzy logic, for example, with genetic algorithm. How to hybridize neural network with fuzzy logic, which is the emphasis Sharif probably asked last class. Neural network also with the genetic algorithm, how to hybridize. And we will discuss these hybridized models. I hope we can have maybe at the end of the let us I don't know, maybe after we probably finish the fuzzy logic in next class or 2 classes. We still have 2 classes in fuzzy logic and 1 or 2 in neural network, and then we can allocate 1 class for hybrid techniques. We have genetic algorithm or any other technique, evolutionary technique in general, and the fuzzy logic and neural network, inshallah. Okay, so any other question, ya shabab? Okay, so if there is no other question, then we can stop recording and end our class, and have a nice weekend, and see you inshallah next week. Hopefully, I don't know whether you know طبعا the Ramadan times. Our class inshallah in Ramadan will start at midnight up to 1:15, as you probably know. So we will take suhoor together inshallah.
Inshallah.
Probably the